Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Right, so a capacitor has turned up. I actually ordered a few different ones, and this is the first one that turned up, which I think is probably good enough anyway. It's a Vichy, I think it's 40 volt, 105 degree, 56 UF. I think that's what the code there means. Can we get close over, you can see it. There we go. Right, I believe this is good enough. Now, the original one 5800 UF, this is 5600 UF. So the this is slightly lower value, but there's a 20% tolerance of capacitors, so it should be okay. I'm going to check it anyway and to see what we actually get out of it. I wish it defaulted 100 Hz. There we go. So 5.58 millifarad, 5.6. See, it's charging up a little bit now. So 5.6, basically bang on value. So Vichy, good quality brand. So we're well within the 20% tolerance on that thing. Who knows what the original tolerance was on this one? I mean, it's probably 20%. Typically, it's 20%. So 20% of 5,600. What's that? I don't know. I have to work that out, won't I? Oh, it's too early to do maths. Okay, 5,800 times 0.2 equals, could be 1.1 UF up or down, right? Based on tolerance. So it could be closer to 7,000 UF or as low as was it 4.7 UF or something. Is the tolerance range on that cap if you're shooting 20%, which is typical. So I think using a 5.6 is absolutely fine, so I'm going to use that. So unfortunately, the one issue is that this is a screw-in type, and although I can get screw-in types, they're horrendously expensive. This capacitor here, I think, was about $7 or something like that. If I got the screw-in type, it's about $40 or $50, something like that. About $50, I think it was. So yeah, it's horrendously pricey. So well, I'll just solder one in. I'd like to keep it original by retaining that screw-in type. For that kind of money difference, it's just not worth it. There's nothing wrong with putting a solder one in, but I would have preferred to keep it original. But right, so let's get this thing out of here. I've got to take the plastic cover off the other side yet. So I'm just going to take one screw out. I'll take the other one out afterwards so it doesn't just drop completely out. Let's tip on this side. So there's that plastic cover just there. You can see what I'll take that off so I can get to the capacitor, which is floating around in there now. I've already loosened these up because I've taken it off once already. They were really tight before, but now it comes off quite easily because it hasn't been removed for how many decades. Right, let's put this somewhere where I'm not going to lose it. So let's just get that unscrewed. Not the easiest place to access. But that'd be easy if I took the thing off the back panel. I might even do that yet. So there's a cap there floating around, which I need to get out. Yeah. Well, this being a pain now, isn't it? Pull this plug off. That'll make it a bit easier, won't it? There we go. There. So that's what was in there. 40 volt, 1500. Minus 10 plus 75%. Plus 75. It could have been double the value almost. So it could have been 10,000 UF, but no less than 5.3. So yeah, so it's within the tolerance of what this capacitor was expected to be. MEPCO. Yeah, well, there's a closer look at it in case you want to see the specs on it a bit better. Alright, so that's what was in there. So a bit of a size difference. Same diameter, but almost twice the length. That's okay. Now, I've got to make sure I put this back in the correct orientation. It's going to be a little bit tricky to do this actually. I might take the transistor bank off the back so I can get through the back panel. That'll be a lot easier. Let's do that. Now I can get to it dead easily. There you go. Right there, nice and easy to get to now. Makes my job a bit easier. So the front panel buttons pushing in. Not really meant to stand on the front, but anyway. So I've got to get the polarity of this correct. Obviously, so negative is going to be this way up. Suit those holes. Now which holes, because it's got different holes here I can use. Just need to see which one suits it best for doing it. Well, I could use either one actually. I think let's use the originals. Tip that back a little bit. So I'm going to use those two there, which are the original ones which you use for the screw. So you can see it's not a wonderful fit, but if I tip it to one side, so like that, it's probably going to be better. And I'll solder it to the one edge, and I'll probably maybe stick a bit of wire across here as well to try and brace it in across the back of that hole as well. It's not the best setup. I would have definitely preferred to get a screw in tight, but they're just too bloody expensive. It's ridiculous. Alright, so let's get some flux on here. Just want to put some fresh stuff on, since it's not been soldered before, or not for many years. It is 10, but that's from many years ago. Just want to get the best chance possible working okay. Pre-solder it, then I'll put the part in. Heat's being sucked out. That's okay, I kind of expected that. Might have to increase my temperature slightly here. I'm struggling with it. Need more heat. More heat! Was on 310 and now got to set at 350. Just needs a bit more power behind it there just to get that to go. Still wanting to stick. There we go, slightly better. Might take a bit of effort to get this one done. There you go, that's okay. I did manage it in the end. Probably because it's a true hole as well. It's probably double sided actually. I should have a look. Probably is. Yeah, double sided as well, so that's not helping. Okay, so there's the part. So you just put some solder on these to get it started. Probably doesn't need any flux on these, I'll find out I suppose. Yeah, that's alright, that's all good. Alright, let's shove this through and solder it in. Make sure the polarity correct, always double check the polarity, triple check the polarity, quadruple check the polarity. I'm doing this a bit kick-handed because I'm right-handed, but I'm trying to hold it in the left hand. Right, so I want to go that way around with it. Yeah, that's in there. Do this on here too. Kind of sort of go one to the other and make sure it's turned all the way around. Don't want any gaps in here, I want it to be as close as possible. Alright. Just get plenty of solder. I mean, being a double-sided board is probably fine actually because it's going to attach to the bottom as well, or the top side of the board. It's got pretty good adhesion there because it's got a really nice thick plated through hole as well. So I'm pretty sure that's going to be absolutely fine as it is. Okay, so that's well soldered in now. I don't think it's going to go anywhere. It's nice and solid. that should, in theory, fix the unit. I don't think it's going to need any more reinforcing. I mean, it seems okay. It's got a nice fillet across the inside of the hole there, and because it's double-sided board, it's gone on to the other side as well. So it's nice and solid there. I think that's going to be fine. I don't think I need to put any bits of wire across there. If it's a single-sided board without the through holes plating, then yeah, I probably would be putting some wire bracing across the front of the holes there just to give it something extra to hang on to. But in this case, I don't think it's actually necessary because it's got the plated through holes which are really solid anyway, and the top side traces too, so it's fine. Okay, let's clean this up. I often get asked what this is. It's just IPA, right? Isopropyl alcohol. Now you can get it in spray cans and stuff like that, or it's often you can get it as like PCB cleaning or flux remover stuff. It's basically IPA. Alright. Now this IPA does actually have a little bit of water in it. I do have a little bit in there mixed in because I use it for cleaning and all sorts of stuff. Right, so it's only probably about 5% water. Just very small. Just helps with cleaning. You don't need it for gluing flux, but if you're cleaning like front panels stuff like that little bit of water helps to get any dirt off. So that's why I do that. It's quite a common technique. Just put a slightly diluted IPA. Such a small amount that it doesn't actually matter, because it will evaporate off pretty quickly anyway. So no real problems there. I mean, this IPA I'll get, it comes in bottles. So there you go. This is what I actually get it in, as this stuff, big bulk bottle like this. It's far cheaper to get it like this and decant it into small containers than it is to buy spray cans of it. It's far cheaper. So there you go, it's in place, correct polarity. I'm going to drop this back on again. I'll do it this way up because it's a bit easier with the screws because they won't fall out. So I'll sit it in place. It's a bit closer to the camera, so hopefully it's alright. Yeah, zoom out slightly more maybe. But I'll probably say this over and over again, but when you bolt things together, don't do one screw and tighten it up. Put them all in first, then go around and tighten them. That way you know they're all aligned correctly. Otherwise you might be trying to force a screw in when it's not quite aligned right, and you can actually damage the threads and stuff like that. So it's just best to do it nice and gently, and it doesn't really take any longer, but you end up with a better result and you don't stress anything. Okay. Plug that all back in. Get it lined up, it'd be great. Okay. Alright, so in theory that should all be good now. Let's put that plastic cover back on. I do like these little tabs I use to hold things together because they are nice, but you have to be careful. They do get a bit fragile over time, so you have to be a bit careful with them. Don't trip them too roughly. They can break quite easily if you're not gentle enough with them. Any sideways motion, you will just snap things off. They are fairly tough, but all plastics eventually age and get a bit brittle in the end. Right, so it's ready to flick this thing around and power it up. I'll get the scope set up, I'll change the camera angle, stuff like that, and look at the scope, and we'll reprobe the capacitors to make sure they look okay. Okay, so I've got the power plugged in. I'll turn it on first, just check to make sure things light up okay. No flickering or anything like that on the display first. Then we'll probe the capacitors and just make sure, double check. And it helps if I actually turn the power on first. Hold on. Waiting for my Variac. Oh yeah, still got to change that fan. No flickering, all looks nice and solid. Waiting for a new fan to arrive. So the display looks fine. Okay, let's probe around, so look, let's see what we get. So minus 15 volt rail. There's a little bit of ripple there, just a touch, but it's not too severe, not like it was before. So maybe the capacitor is a little bit on the small side. Plus 15 volt, yeah, much the same. Is that on 5 volt, was it? Yeah, 5 volt rail there, 5 volt rail there. So actually, it's no worse than the other rails. That's the minus 5 volt. It's got a little bit of ripple on that one. So, yeah, I think it's fine. Nothing wrong with that, I reckon. Right, so one of the things I've got to do now is actually adjust the power supply to make sure it's all good. So I've already got the meter hooked up onto the test point. So I've got TP1 as ground, and the next one over, I think it's TP2, is the constant 15 volts, which is there even if the unit's powered off. I've turned this light off, so it's glowing on the screen here, so it might be a bit dark in this area. Sorry about the bloody noise, this is horrendous. But TP3 is the one I'm supposed to be measuring on initially for that test point. I've got a bit wrong. I was supposed to switch the supply, and it's supposed to be within 10 millivolts. So right now it's actually out of spec. So we'll give that a bit of a tweak up, and we'll get that better. So it's drifting slightly, I'm not 100% happy with that pot. I think the pot's particularly good. Twirl around again. Trying to get it clean. Wow, that's so touchy. But there we go. I'll leave it there. I reckon this should have been a multi-turn pot, really. I'm so sorry about the noise, I can't do much about it. Okay, now the next thing, I need to check the other rails. I'll do our specs here, what it's supposed to be. So what's the next one? That's the minus 15 volt rail, and it's supposed to be plus or minus 0.2 volts, so that's within spec, that's fine. What's that one? Plus 5 volts. That has to be plus or minus minus 0.1 plus 0.2. It's actually slightly high. Very slightly high, that one, so I'll keep that in mind. Check the next one. So the minus 5 volts is minus 5.2 to minus 4.9, so that's very slightly low, by about the same amount, so they're both slightly out. It's a 40 volt rail, which can be 40.5 to 42.5. So that one's okay. Right. Shut that off, that's driving me nuts. I really need to get the fan done. I'm waiting for a new fan to arrive. Once the fan arrives, I'll be changing it, obviously. So, so the plus and minus 5 volt rails are both slightly out of spec. Just very slightly. So I might actually have to look at what can influence that. I may have to tweak that 15 volt rail, see if that affects them. Even though I've now got a 15 volt rail bang on. Right, so if I'm looking at the circuit diagrams for this thing, which I may remember to show you if I recalled that, the plus and minus 15 volts supplies go to some op amps which are part of the 5 volt regulator circuits. So it's got some voltage comparators or something in there. So if the 15 volt rail or minus 15 volt rail is a bit out of spec, it may affect the 5 volt rails. So I'm going to just go back, I'm going to remeasure the 5 volt rail, I'm going to just tweak the 15 volt supply, see if I can get those 5 volt rails in spec, and then I'll go back and look at that 15 volt rail and see if I can get that all the rails in spec at the same time. So I think it might just be influencing very slightly. So let's try that one there first. Back to noise. So we'll drop that down a lot to get that in spec. I mean, they're both in spec now. Down a 15 volt won't be. So the 15 is now 14.7. So yeah. So the best I can do then is put the 15 volt rail as close to the bottom end of the spec as possible and leave it there. Okay, so it's right at the bottom end of the spec, 15 volt rail. So it's slightly over on that one. And that one. That should still be okay, I expect. Yeah, still in spec, that's fine. And Mars 15 is still in spec as well. Well, I've got to replace that fan. I know I keep repeating myself, but wow, it is noisy. Okay, so that's as good as I can adjust it to. I might have to look at the actual circuitry there to see if there's something I can do to bias it a little bit to try and create those voltages. I mean, I don't know how perfect those voltages have to be. It's only slightly out, you know, it's 0.1 volt, less than that. So, yeah, I prefer to keep it exactly as specified in the manual, but I don't know, maybe there's some parts which have aged a bit there, so it's gone off value. I have to analyse circuit diagrams for that. So this is the power supply section here of the 5 volt rails. Is it 5 volt, 50 volt and 40 volt rail? Yeah, so this is the 40 volt rail and there's the 5 volt rails over here. So that's the second section of the supply regulator. So those are those pass transistors here which are on that A29 heatsink. And this is the plus 5 volt rail, and this one over here is the minus 5 volt rail. Now as you can see here, you've got these op amps here, there and there, which have both got 15 volts plus and minus supply on both of them. And these are then driving these transistors, which are then driving the main regulators, which are pass regulators, or pass transistors, which then go through and supply the rails. Now, so this bit here is the actual reference. This bit here is figuring out what the voltage should be and adjusting. So it's got a feedback here for this line. That one there's got feedback going in. This one here's got a feedback going in. Okay, and it's got a voltage divider here. So if you look at the plus 5 volt rail first, there's plus 15 volts here with a 4220 resistor, and there's a 2150 resistor here. So that's a voltage divider. All right. So that's then setting the reference voltage it wants at that pin, and then it's comparing these two pins, the input from here, which is probably filtering, feedback and filtering, is it? I'm not quite sure how this is working. I don't know what it's doing, but so it's got this drop through there. It's got some feedback through that diode, so that's going to be dropping it down a little bit anyway. I don't know what it's doing. It's obviously filtering those caps, smoothing as well. So yeah, so it's comparing those two pins, and then it's outputting what's required in order to get the right voltage coming out. And the same on the negative side, it's got filtering caps in there, reverse diode that side, you know, so that's the negative rail, so it's got negative passing through. And then it's got the sampling coming from this one here, and voltage dividers on this side. There we go, it is there. So you've got the minus 15 volt rail there, and the ground reference there, 0 volt reference there. So that's the voltage divider section here. Okay, so that's what they're doing, voltage dividing, comparing the two voltages, and then sending out correction voltages in order to close the loop and actually make sure it's running by reference. So any slight variation in voltage is going to be due to these voltage dividers here, or the feedback here. Or possibly aging of this diode, or one of these caps might be aged slightly, which may be dragging the supply very slightly as well. So it's probably just these voltage dividers have gone slightly off value. I'm not overly worried, to be honest. It's just very slightly off, just a smidgen. There's really very little in it. So I could compensate for it by just adjusting these resistors very slightly, It looks like they've been very specially chosen anyway, but you could easily stick a little VR on there, something like that, and things change to the voltage you actually want just by tweaking those resistors. It's doable, but yeah, it's just slightly off value. It's probably just these resistors have aged very slightly and gone a fraction of value. I bet if I measured them, you'd see that the values aren't quite right, quite possibly. But this is why that 15 volt rail, or the negative 15 volt rail even, is influencing the actual supply output, because that's what's controlling the op amps, which are then given the final output. So that's why changing the 15 volt rail there changed the 5 volt reference, because, well, both of them, because it's running through those op amps. So it's changing the supply voltage to op amps, and it's actually shifting the offset very slightly, effectively. So, if I really wanted to tweak these outputs, I could, like this one's, the minus 15 sitting slightly too low, so I could maybe strap a resistor across this one, a high value resistor, just to tweak the value very slightly. The same on the plus 5 volt rail, because the setting's very slightly high. I could easily do the same thing on this one across R45, for example, and strap a high value resistor across there, just to bring it down a fraction. Alright, so I've had these running for a little while now. Now, next thing I'm doing is checking the calibration of the internal reference. This doesn't have the OCXO option, I don't believe. It's just a standard reference inside it. Could be a TCXO, I'm not quite sure. So you can see I've got roughly 10 megahertz on display here. Now what I'm doing, I'm feeding my rubidium standard into the back, right? So that is exactly 10 megahertz, and you can see it's reading slightly off. Now I'm also feeding out, I've put in a little cable here. Now this is feeding out to the Philips frequency counter here. It's reading slightly high, so it's definitely out. So what I'm going to do is adjust the adjustment on here, and expect to get this close to 10 megahertz and 10 megahertz showing up on here at the same time. If I was doing this technically correctly, I'd be using an oscilloscope and check right phasing of the waveforms and stuff like that, to make sure it's all, you know, within phase of each other. And so you hook this up to the scope, hook up the rubidium to the scope, and do a phase waveform. I might even show you that in a second, actually. So I've got a little weird flashing LED down here. I need to look into this and see if that's an issue with the fault, whether it's just a status LED. I don't know. I need to look into it, see what it's actually doing. But let's tune this for now. So it's been a non-metallic screwdriver. This is ceramic. See if we can get out of it. Doesn't want to move. Okay, so it's almost there already. So I think we're just a little bit too far. Well, I should be able to get this 10 megahertz on here at the same time. I've got it right. Okay. So that's very close there. So we'll do the waveform thing, eh? We'll see how that comes out. So the yellow trace is the rubidium, and the pink trace, purple trace, is the output from the A109. Right, as you can see, they're not in sync right now. So when they're in sync, you should see them overlay pretty much. Although, yeah, there's 10 megahertz out. It should be 10 megahertz coming out of this thing. So let's just try and get them to match up. So there's the waveform there. Very touchy. You see, you should be able to get both in sync, but this is very touchy control. So I don't think I'm going to get it exactly right somehow. Just putting a screwdriver in there, even though it's not metallic, it's changing it. So that makes it a bit tricky, doesn't it? Yeah, trying to get this perfect is not going to be easy. Again, I'm probably not actually... I mean, just by putting a screwdriver in, it goes one way to the other way. So, yeah, it's... I'd imagine it's about as close as I'm going to get it without using an ovenised oscillator. So I put it back to this, and it's actually saying bang on 10 MHz on that, on the actual unit down here. See, it's flicking on 10 MHz as well. So, yeah, I mean, I think that's going to be basically there, I think. Right, so next part in this little calibration is to actually set up the RF level detector. So we'll try doing that. Now, it's a special command apparently. So it's in the manual. Adjustment 3 it's called in there, which is page 398 of 433. Anyway, so it's supposed to key in 0.024 special, so 0.024 special, which switches out the 5.25 MHz high pass filter and sets the RF level detector to normal output. Then key in 49.31 special to display the something or other. So we'll say 49.31. 49.31. That's not right. Clear. 49. Clear. 49. This might need cleaning somehow. That's supposed to display the RF level with respect to RF ground. And these steps set the output for an RF level measurement and connect the internal voltmeter to the RF detector output. Adjust A15 R42 detector offset for display between 0.001 and 0.001, or minus 0.001. So it's out of spec. So I need to go basically 0 plus or minus 100 millivolts. So now I've got to find that position on there. So it's A15 board, whoever that is. A15. Detector offset. That one there. Yep, right there. So let's adjust that to try and get 0. I should also say this with no RF input, nothing connected to the jack on the back. Alright. Okay, that's certainly good enough. So I'm going to do some audio testing now. This 8901B Modulation Analyzer requires a new fan, as you would have seen earlier in the video or previous videos. I can't remember exactly how I'll set this up now, but it needs new fan because it's just horrendously noisy and rumbly and noise, and it's awful. You get the idea. So here's my spectrum analyzer here, which has SPO measurements on it, and this is a calibrated device. At least they are when they're new. This is an old device, but it should still be fairly close. And as you can see, it's got my vocal pickup on here. The microphone is just next to the camera, just over here. And the measurement wise, it is 34 centimeters to this front corner, and about 90 to the fan on the back. Okay, and essentially in line with the side here. So it's just off the camera view. It's almost in line with the side, just slightly off angle there. Okay, so when I do the fan replacement, I'm going to try and do exactly the same positioning and everything as well, so it's directly comparable. And I'm just going to show the SPL level and the noise waveform before and after, and we'll see how we get. I thought it might be interesting for you to see it. Okay, let's turn it on. Okay, let's do a measure maximum on there. Right, pretty consistent 80 dBe. Pretty consistent 80 dB, so it's it gives us a nice benchmark there to go by. So 65 dB, 64 dB is like the ambient, because I've got my computer running on the other side of the room there, so it's not dead quiet because of that. But well, we'll change the fan and we'll see what levels we get afterwards. Okay, well, let's pull this fan off and look at replacing it. Now, this is the original fan guard. I didn't put it back on again, and so I mentioned before it's got one screw missing, which is a bit of a shame. Now, this is the new fan guard I'm going to put on as well. It's got like a mesh on it to help EMI, and that'll fit on there just like that. So it's a bit nicer, and it actually then has some kind of filtration, at least. You know, something's better than nothing. So we'll get this off. I think I can actually get the wiring sorted out without taking the thing apart. So yeah, there's the wiring all right there, so I should just be able to take those off there, solder them onto the new one. And it's got a grounding lug on there as well, which I may or may not be able to use because these new fans are plastic. This is the new fan here from Farnell. Now, it actually came with a noise suppression capacitor as well, which I thought was quite interesting. But it's got wire leads, no grounding, so I'll probably have to do something with that grounding lug, maybe tie it to the chassis or something, I don't know. But obviously, being a plastic fan doesn't require grounding, and you can see it's significantly smaller than the original. Should all be the same, at least in that direction. So dimensions that way are the same, it's just a narrower profile, which is fine. But long wires means I can just splice the wiring, and it's actually a little bit easier. I don't want to shorten them too much. I have to try and see what I can do about the grommet here and tying them up inside, so that gives me options later on if I ever replace it again. So anyway, let's get this all cut off here and we'll go from there. A bit of a shame about these old fans failing like that, because quality wise they're going to be excellent quality fans, you know, they are high quality units, but nothing lasts forever, obviously. That's why I have this channel, because nothing lasts forever. Anyway, it's a good thing, otherwise I wouldn't have anything to video, would I? If nothing ever broke, I'd have no videos to make. So, yay. Yay for breaking things. Right. Let's desolder these wires. Get this earth wire off here too, so I need to do something with this. I can't just leave it floating around, it'll probably end up getting stuck in the fan or something. Maybe I can tie it up inside. Something like that, maybe. Have to figure that out. Right. Wire's up to temperature apparently. Let's get these off. Hand's probably in the way, isn't it? Here we go. It's probably a bit better like that. And they are wrapped around, so it's all done nicely, as you'd expect. Problem is now I've got to try and unwrap it. I don't want to shorten the wires. Being a bit fiddly, right? Nah, I might just cut them off. Sod it. This has come off. I'm not going to mess around with it. Too hard. Same with that one. It's just easier. Taking so much time. Right. Get that crap off there. Right. So I need to slice this back a little bit so I've got something to solder onto. Put some fresh solder on and try and get it so you can see what I'm doing. Come on, get on there. Get the old crap off there. I just put a blodge of solder on my bench. That's okay. Didn't melt. Not this time. So let's get some heat shrink. This is probably not the best way of storing it. Yeah. It might even be the right size. Actually, might be a bit small for this, for overlapping them. It might be okay. I'll give it a go. So I'm going to use this wire, or should I shorten it? What do you reckon? I don't like to cut wires off if they're already there. I'm probably going to tie them up anyway inside. Now it's got this grommet which sits like this, right? So how does this affect the fitment with that grommet sitting like that? I mean, this is going to sit like this. That's to allow the wiring to go around the outside, isn't it? If I pull that back through the grommet and just shove the other wires through, that'd probably be okay, wouldn't it? Although it's got this bloody earth tab which is soldered on. Will it pull through? Yes, it will. Great. Alright, so we'll do this. We'll shove the grommet through there. Then we'll tie it all up inside, probably have to take the top cover off and just tie it in. It's not that big a deal. These wires here are very thin. Anyway, there what they are. So what I should probably do actually is power this up before I do much else and verify that the thing actually works. If I can get the heat shrink over that bit, it'd be good. Come on. It's catching on it. There we go. Let's just quickly plug power in, see if it actually goes. Then I'll carry on from there. No reason why I shouldn't go, but you never know. Find a switch. Well, it rose, and it's definitely quiet compared to the other one. Huge difference. So yeah, I'm going to take the top cover off this and tie all these cables up inside. I'm going to have to do that, I think. So that's okay though. Right, which way did this thing go originally? That was the outside. Fan direction, does it say? It does not say. But if you look at it, if you look at the fan profile, it'll be blowing inwards. So that's fine. Which way is inwards on this one? That way around. So, no problem. No problem at all. That's fine. So let's heat shrink these up. Now there is a difference here, because this casing now isn't going to hold the fan like it was before. I actually might have to leave the thing off, because the fan was basically filling up the casing. So if I show the casing like this, right, it's full width. So this fan obviously isn't going to do that, so the casing isn't going to hold it. So what I think I'm going to have to do is just forgo the casing. I'll keep it at one side in case I have to change the fan again one day, but these screws are probably going to be massively long now. But I know it's got a big clearance inside the back of the fan, inside the housing there, so it shouldn't really be a problem. Probably not ideal, but yeah, you have to be fine. And the comments popped out. Let's get this other one. I would actually like to find another screw which will fit in here. Don't like having odd numbers. Should be even numbers. Always even numbers. You should never have odd numbers. No, usually not anyway. Alright, so that's those on. And it is rubber mounted, so it should be fairly quiet anyway. I'll have to do something with this. Let's take this cover off. I'm not going to fit this obviously because I haven't bothered. Probably isn't necessary. I was hoping to avoid taking the covers back off, but this wasn't that big a deal, was it? Not that hard. Apart from trying to keep my arm out of shot. Oh, that's right, it's got this cover on this side. Duh, I'll take the bottom cover off. I think that pops out when he does it. No. I'll take the bottom cover off, not the top cover. I'll come right back once I've done that. Okay, so I've already gone ahead and tied the cables up inside here, so it's all nice and tidy. Well, as tidy as I can get it without getting my hand in there. So that's all out the way. It's not even going to hit the fan or anything like that. I'll slip the grommet back in again as well, which popped out before. Let's rotate this around. So you can see there's the grommet there, and the cables here. I'm not happy about the cables being up here though. You know, that's what the shield was supposed to be for, to make sure the cables didn't get hit. So I don't know, maybe I can maybe I could took one of those screws out actually. If I took that screw out and ran that one straight through, that could then hold the cover on. Maybe I could do it that way. And then get another long screw to hold the other side, so you've got two holding the cover, two holding the fan. That'd probably be right actually. So I might just do that actually. I'll come back. So there you go, I've fitted that cover. I found another screw which is very similar size and run that onto the fan. So it's got two screws holding the fan, two holding it out of cover, just to keep it a bit more protected and things like that. I suppose you could have actually, I could have put that mesh on the outside, but really it's fine with it. At least it's protected there, it's a bit more tucked out of the way, it's less likely to get damaged. Obviously it means that if I do want to clean it, then I need to take the whole thing off, including the fan. But so if I ever get to that point and I have to put it back on again, then I'll put mesh on the outside instead. But anyway, so now I'll put it back together and we'll do another sound test on it and see how it goes. Right, so I've got it all ready to go. Let's power it up. Start with this. I've already positioned the microphone be the same distance as it was before from the microphone, about the same angle and that sort of stuff, so it should be comparable. So let's power it up and see what we get. Again, we'll do the Spectrum first and then we'll do the SPL and see what we get. Doesn't even show up. The fan is running.
Nice and quiet. Okay, let's do SPL. Yeah, 64 dB. It's only marginally louder than my computer, I think. I mean, my computer running over there, which is, you know, 6 foot that way or something, is about the same volume level as this, really. I mean, this isn't actually adding to it at all. That's how quiet it is. So that's a huge improvement. That's actually, you know, you can put up with that sound level now because it's really quiet. So these little fans, although they're fairly cheap, they're a very low noise level. So that's the part number on them, 1568508 from Farnell. And there's a little sticker on the back if I can get you to show you that. Hope it will focus on it. So, so it's 92 by 92 by 25mm, 115 volt AC, and it's a sun-on fan. And I've got 2 more of those. That's good because that's a nice quiet fan. I actually quite like that. That's good. Job done.